Hello, everybody. Welcome back to our live stream. I'm, of course, Scott Ford, and this is a series of live streams that we're doing covering computer maintenance, or specifically the CompTIA A Plus certification, the 1101 and 1102 exam. Appreciate your patience as we've been trying to figure out our sound stuff. I think I finally got it set up right. We configured the microphone, and hopefully we have everything the way we need to have it. So what we're going to do today is we're going to finish off our Unit 1 conversation, the basic PC, as we're taking a look at some of the basic information that you need to be aware of as you continue your studies. Now, keep in mind, all of this, pretty much all of this is going to be covered in more detail in their individual units as we move through the material. So, for example, we've talked about input-output devices. We have an entire unit just on that. We talked about processing. We have an entire unit just on CPUs, motherboards. We talked about storage devices. We have entire units just on storage devices. So we will expand upon all this information as we go through this course. So don't worry if if you're like, hey, wait, there's should be more. I know. We'll get there eventually. So just hang with us for that. Let me pop this up on our screen right now. Whoops. There we go. So we have in the background the live feed. So if somebody comes in and goes, what are you doing? We can confuse them a little bit. Wait, you're there and you're there. And you seem to be doing the same thing with a little bit of a time delay. Anyways, let's get into our conversation by looking at peripheral devices and connections. So peripheral is a collective name for all the external devices that you can plug into your computer. So all these external things that you can plug in, whether they be keyboards, mice, for example, I got a Stream Deck. This is also considered a peripheral. And the most common ways to plug things in include through USB, Firewire, Thunderbolt, Bluetooth, and RF. So taking a look first, come on, there we go, at ports, plugs, and connectors. These have very specific meanings. So, for example, a plug is something that goes into a port, i.e., you plug something in. So if I ask you to plug in a TV or a monitor, you're plugging it into a port. A port accepts a plug. And of course, if you ever are confused or forget which one does what, just call them a connector. It's a kind of a generic term for both of these. So if you ever forget and you're having to talk to somebody, just say connector and you got your bases covered. So quick note about serial. I think it was the very first video in the Unit 1 lessons, we talked about binary. We talked about bits and bytes. Well, serial is when we send one bit at a time. And for a little while, very, very long ago, in a galaxy far, far away, and then Lucasfilms hits us with quit talking about that. Anyways, but back in the old days, we kind of moved towards parallel, because we thought parallel would be faster. Now you send one byte at a time versus one bit. And so we started having connections for parallel connections. We had hard drives connected through parallel connections. We had optical drives. We had printers. Well, it turned out it wasn't as fast and as efficient as we thought it was. And so we moved back to serial. But today's serial devices are a lot different than the serial devices that I used when all of this was dark brown. So many moons ago. So let's take a look at what our current serial devices do. First of all, they are hot swappable, meaning you don't have to turn the power off on the computer to plug or unplug these things. They are faster than older connections, and you have much longer cables that you can use. And we use serial connections for pretty much everything nowadays. The idea of parallel connections is passé. We've moved away from that for the most part. I'm sure you can find some stuff out there. In fact, I was doing a boot camp with my students. This is during a week during vacation. And of course, I have to stop at Dunkin' Donuts because, it's wicked good. And my family's from Massachusetts, so I gotta get my Dunkin' and get back in my car. So I got my Dunkin', and they had this like really weird contraption hooked up to their printer, where it was a parallel connection. So being the true geek, I took a picture of it and shared it with the students when I went to class. Moving on. All right. So taking a look first at our first very popular connection, we have USB. USB stands for Universal Serial Bus. It is a very, very popular way to connect peripherals to your computer. Let me move my thing over here so I can see if there's any chat there. Okay. So it's a very popular way to connect peripherals to a computer. They are hot swappable. And we've had just this insane amount of evolution over the years with USB 1.1 all the way to USB 3.2. And I am sure many more yet to come as they get faster and faster and faster. Then we have FireWire. FireWire is an older technology. Well, USB and FireWire about the same time, but FireWire has been discontinued. It was created by Apple, TI, that's Texas Instruments, and the IEEE, specifically the IEEE 1394. And we used to have to memorize that, by the way, back in the old days of the A+. But the IEEE stands for Institute of Electrical and Electronic Engineers. It's really not important for the A+ exam, but just know that it used to be the 1394, the IEEE 1394, and it was designed really for video output. So video has always been this massive just hog of bandwidth. It takes up so much just oomph to get the video through. And USB really couldn't handle, earlier versions of USB couldn't handle the speeds needed to capture live video. So for example, this computer is not only capturing live video, and HD at that, it's also streaming it online. Well, in the old days, forget about this with a USB connection. And so FireWire was this way that we could live capture video onto a computer real time and edit it and do all sorts of production values while it was going on. And that was why it was created. Well, USB has, evolved over the years. And so IEEE 1394 or FireWire has been no longer actively developed. So now what we have is something called Thunderbolt. This is the successor to FireWire, and it's designed to be a high-speed peripheral connection standard, and it was introduced by Apple for its Mac OS computers. You can find PCs that accept Thunderbolt. So for example, I have a brand new computer. It is a Nitro 17, and it's pretty sweet, actually. I just got it about 2-3 weeks ago. And on the back, I do have ports that accept Thunderbolt connections. So kind of a cool thing there. So originally known as Lightspeed, like I said, you can find it on some PCs as well. Then we have Bluetooth. Bluetooth is this really cool way to connect devices together through a wireless technology. And it's named after a Danish Viking who unified Scandinavia. And it's designed to connect, again, consumer devices into what we call a personal area network, or a PAN network. And it uses radio technology. Connecting devices through Bluetooth is something called pairing. You might have heard your devices go, pairing. So for example, if I grab my earbuds and they're not connected, I'll plug them in my ear, I'll put them in my ears, and I'll hear pairing. Devices paired, so that is called pairing. Radio frequencies, outside of the context of wireless, the standards there, usually when we're talking about radio frequencies in this context, we're talking about a proprietary technology. We have an entire unit just on wireless networking, which is much later on in the course. All right, types of operating systems. So we have 32-bit and 64-bit operating systems historically for the last, I would say, 20 plus years. 32-bit being very popular back in, I remember teaching this in 2004 to 2008 when we started the big transition from 32 to 64 bits. This has to deal with the CPUs and the registers internally. We'll delve into this in much more detail later on, especially when we talk about CPUs. But most operating systems run in 64 bits. So if you were to go to Best Buy or Micro Center or any big box store, you're going to probably be getting Windows 64 or Windows 11. That's a 64-bit operating system. If you download a distro of Linux, you are most likely using 64 bits. If you download or have a Mac OS, that's the Apple operating system, you are, again, using 64 bits. And like I said, we dive into all of this in much more detail later on. Now, what if I was to tell you that there were only 3 operating systems on the market? Windows, Mac OS, and Linux. Am I telling you the truth? Are there only 3 operating systems on the market? Well, kind of, if I'm asking the question, obviously the answer is probably no, there's more operating systems out there, or I'm just playing mean games. But yes, there are more than 3 operating systems on the market. We, in fact, have operating systems for mobile devices. We have operating systems for workstations, servers, and embedded and firmware. So looking at mobile devices. Now, back when I was originally teaching the A+ certification, we really didn't have mobile devices on the exam because, maybe you knew somebody who had a bag phone, or maybe they had one of those new BlackBerry phones. Well, now mobile devices have become so ubiquitous, so just everywhere, that we need to know a little bit about them. So with mobile devices, we have different operating systems. 4 of these, or 2 of these are dead. Let me try that again, actually using my brain. We have 4. Of the 4, 2 are dead and 2 are still very much being used. We have the BlackBerry operating system, Windows Mobile, iOS, and Android. BlackBerry operating system used to work on the proprietary BlackBerry smartphones. They don't make them anymore. You can still find BlackBerry out there. It's still a viable company. It's still out there focusing on security. Windows Mobile, Microsoft wanted to get in on the act as far as operating systems for mobile devices. Windows Mobile is also no longer being used. So the last 2 that are still actively being developed that people will use is iOS, which was formerly known as the iPhone operating system, or iPhone OS. And it's a proprietary operating system designed specifically for Apple hardware. And it is the second most popular mobile operating system. Now, speaking as somebody who's a Droid user, that's right. iOS is the second most popular. So, anyways, the other one, and obviously my preferred favorite, is the Android operating system for mobile devices. This is the most popular mobile operating system in the world, and it's based on a modified kernel of Linux. We'll talk about Linux in just a second. Most versions are proprietary. And here's the cool thing. Most times it is your phone provider who determines when you get those updates. And so an update might come out, but your phone may not get it because your carrier hasn't tested it with their equipment, or you might have the carrier release the update, but it might be on your phone and not on someone else's phone because it hasn't been tested or approved for the other phone. So usually the updates for Droid or Android is handled by your phone provider. Workstation operating systems. This is what we are typically familiar with. This is the stuff that's on your desktops or your laptops. And the big 3 that we need to be aware of are Windows, Mac OS, and Linux. So Windows has been around for a very long time. They've had several different editions over the years, and it's considered a GUI or graphic user interface. You might also hear a term called WIMP. This stands for Windows Icon, Menus, and Pointers, and we'll look at Windows in much more detail later on. We talk about installing and using them and making sure it works. So we will look at Windows in much more detail. Believe me, you'll need more details for the A+ exam. So Windows 10 was released in 2015. It was designed to replace Windows 8.1. There was no Windows 9. Windows, and we'll look at this later on in another unit. The math doesn't math on these things. Sometimes they're named arbitrarily. Sometimes they're named after years. It is what it is. And if I had $1 bajillion, I think I could name it anything I wanted as well. So Windows 10, believe it or not, was supposed to be the last version of Windows. When Windows 10 came out, they were like, this is it. No more Windows 10 or no more Windows anything. It's Windows 10. It's going to be around. We'll release updates, but there's not going to be a Windows 11. Well, that was a lie because there's Windows 11. In fact, they're looking at discontinuing service on Windows 10 this year in 2025. So Windows 10 has several versions. There are 12 versions of Windows 10 available. Windows 10 is the most typical use for home users. It's found pretty much by default when you buy a computer from a retail store. Windows 10 Pro is geared for professional environments. This has the ability to join domains. We'll look at that later. It has some cool features, so integration with Microsoft OneDrive. Now, when I say this was a cool feature, it was a cool feature before Microsoft was all in your face with the OneDrive, right? You'd open a file and you'd want to save it back to your computer. And then you're just like, oh, you just saved it to OneDrive. And you're like, I didn't want to save it there. So when it was originally introduced, it was a cool feature. Built-in anti-malware protection using Windows Defender. Microsoft kind of had enough of unprotected computers, rightly so, because of just how many computers are infected out there. We'll talk about that in more detail in security. And Cortana was introduced by Microsoft. This is their version of Siri or Alexa, except it sucks. Moving on. Windows 11 is the current version of Windows. It was released in 2021. It is a free upgrade if you have Windows 10. In fact, it will tell you it's a free upgrade and you should upgrade because it's the absolute best. No, you really want Windows 11. Do you really want to keep using Windows 10? No, you want Windows 11. I mean, it's there. Some of the differences between Windows 10 and Windows 11 is the user interface change. So, for example, they moved the start menu. I guess they didn't learn their lessons with Windows 8. But there is good news. If you don't like your start menu in the middle of your screen, you can, of course, move it back to the left side of your screen, which is something I did the day I bought my new computer with Windows 11 on it. Skype is not bundled anymore. Teams is integrated, whether you like it or not. You have Teams. And Internet Explorer is finally dead. Hallelujah. Amen. And it's replaced by Microsoft Edge. And if you ever try to download Chrome, Microsoft Edge will tell you, but I'm good. You don't need Chrome. Stay with me. I'm cozy. I'm friendly. Although I have to say, Edge has now integrated with ChatGPT, I believe it is. So it has built-in AI controls. I don't know if that's a good thing or not, but there it is. Mac OS, this is a proprietary operating system designed to run on Apple computers. Apple desktops and laptops was built based off of something called Unix. Unix is the granddaddy of operating systems. Mac OS 10 was originally released in 2001. Mac OS was originally known as Mac OS 10, then OS 10. Mac OS is the second most used operating system for desktops. Apple uses code names for their Mac OS versions. I will say that this has shown up on exams before in the past, both the ITF Plus as well as the A Plus exam. So know kind of what they name them after. So originally it began with big cats, so lions, tigers, not bears. Then they ran out of cats, and so now they name them after places in California. To see the version of what you're running on your Mac, just click on the Apple menu on the top left and click on About This Mac. Then we have Linux. Linux is, and this is kind of a funny thing, there is no operating system called Linux. What? They're distros of Linux. So you can't just go online and download Linux. You're going to download a distro of Linux. So like Ubuntu or Mint or whatever, but there's going to be different versions or different distros of Linux built off the Linux kernel. So lots of variations available. Variations are known as distributions or distros. And some of the most popular distros are Ubuntu, Debian, and Fedora, among many others. And there are tons and tons and tons and tons and tons and tons and tons of different distros in Linux. If Linux is something that you enjoy using, there is a Linux Plus certification that you can pursue also through CompTIA. So boot disks, some Linux distros can boot from a removable drive, which is very cool because sometimes we have to use this drive, this bootable version, to troubleshoot our computers. Sometimes this is the way we can run anti-malware stuff. We can check hard drives, all sorts of things. Or if you have to use a public computer and the public computer, you don't trust that it's clean, it might have malware on it, you might have keyloggers, you can actually boot to a thumb drive with a Linux distro on there and run it, just avoiding all that nasty stuff. I will say this, that does present a security warning. There is a security issue because it will bypass all of your local controls on that particular computer. So if you have a logon required to get into that computer, Windows logon to access that specific computer, this bypasses all of that. Server operating systems. Servers are a different beast altogether. These things need to provide special resources for clients and throughout the organizations. These are typically very, very powerful computers and expensive computers at that. They usually require specialized training, so people can make a living just knowing how these operating systems work. The three server operating systems to be aware of is Windows Server, Mac OS Server, and Linux Server. It is my understanding that Mac OS Server has been discontinued, but Windows Server and Linux Server are very popular. Again, you can actually get a Server Plus certification and make a career administering and maintaining servers and configuring them. So that is something that, if you're into that, that is an option for you. Then we have embedded operating systems. These are specially designed operating systems used for specific devices. So, for example, if you have a PlayStation at home or an Xbox or something from, I'm drawing a blank here. Nintendo. There we go. Nintendo. It has built-in operating systems. This is considered embedded operating systems. Also, you can find embedded operating systems in like your home router. I've got a smartwatch here. It's got an embedded operating system on there. All sorts of different things that have embedded operating systems on there. Because they are designed specifically for that specific hardware, they are usually extremely stable, meaning they don't crash very often. You can, in many cases, either update them. In fact, you probably should update your embedded operating system, or you can actually replace it. So, for example, if you want to really geek out, you can put a different operating system on your home router. You can swap it out for something else entirely. All right, we're going to hop into our last part of Unit 1, and this is focused on troubleshooting. Now, let me give you some heads up on how CompTIA exams handle troubleshooting. They are not going to ask you to just list all the steps of troubleshooting. They're not going to say, okay, here's a blank piece of paper, write them out. They're not going to do that. What they will do is present you with scenarios. So, for example, they will say, Larry is asking the customer these questions about this. He's trying to find out when the computer was last booted. What step is he engaged in? Or they just fixed the computer, everything works. What is the last thing that they should do? So you need to know them in order and what they do. And the cool thing is they actually make sense if you take a look at the steps. So just a heads up on that's kind of how they use these questions on the test. So taking a look at troubleshooting. Now, there are two models that to be aware of. There's a CompTIA troubleshooting model, which is on the exam. And then there's the Mr. Ford's type of computer problems that I have found very helpful over 20 plus years of doing this to try to figure out where problems are at. So just my model first. This is what I actually use to figure out where the trouble exists so I can focus in. This is not on the test, but I find it very helpful to actually fix computers. The first layer is hardware. There's an actual problem with the physical hardware. So, for example, in my classroom right now, we have 4 computers that we've put together. The 4 computers, 2 of them are working and 2 of them aren't working. Now, they're not booting up correctly. This is a hardware problem. We think it's a problem with the power supply. And so we're able to go, it's a hardware problem. So we're not looking at operating systems or applications. We know it's a physical problem with the computer. And so that kind of gives us a ballpark of where to look for the issue. By the way, we do have a Discord channel, and I posted our PC parts picker list of all the components that I use for this computer. Check the description. I'll have a link or something to the Discord channel. If I don't do it in this one, I'll have it in the next one. Then we have BIOS and drivers. This is how the operating system and hardware communicate with each other. So, for example, as we were putting together the new computers, we booted them up for the first time, and the video wasn't right. It was really kind of ugly looking icons and everything was off. That's because the video card was working, but we didn't have the drivers that told the operating system how to talk to it. Once we downloaded the drivers, video worked just fine. Then we can have an operating system problem. This is a problem, for example, with system files. Something has become corrupted. Maybe there's a setting off somewhere. Maybe it's malware that's messing with everything. Then we have applications. Maybe everything's working on the computer, but one program keeps crashing. Maybe it's faulty. Maybe there's a bug. Maybe it's become corrupted. And finally, the last problem, and if you don't have a piece of paper, you need to write this out. The last problem is what we call an ID 10, that's 10T problem. So an ID 10T problem. I'll let you write it out as I have a sip of my coffee. So if you've written it out, what does it spell? It spells idiot, right? ID 10T. It's an idiot problem. It's a user error. Okay. User errors happen to the best of us. It's not always just because somebody's an idiot. It's because we messed up somewhere. Maybe somebody has caps lock on when they're trying to put their password in. Maybe somebody forgot to do something. Maybe they left it unplugged. Maybe they turned a power button off somewhere. It can be a user error. And, just whoops, it happens to all of us. By the way, the other abbreviation for that is called PEBCAT. The problem exists between computer and chair. All right, and finally, let's get to our CompTIA troubleshooting model. Like I said at the beginning of this particular section, you need to know the orders and the steps in order. You will not be asked to write them out, but you should be able to organize them as what's first, what's second, what third, what's fourth, and know where the steps are located at as far as, okay, I did this, what's next, that kind of thing. So without further ado, here are the steps of the CompTIA troubleshooting model. We have identify the problem. Okay, your computer's not booting. Well, there's a problem. What the computer's not starting. The computer's not getting any power. There's a problem. Establish a theory of probable cause. When was this always working? Did this computer work? And by the way, ask to make sure, was this working before the problem exists? You'd be amazed. Sometimes I had a customer one time. I asked them, I said, did this ever work? And they were like, no. I said, well, take it back to the store. Here's your solution. But make sure it was working to begin with. So you're going to ask questions. So for example, the computer doesn't turn on. Computer just doesn't start. Okay. So the computer doesn't start. There's no power to the computer. Was it working before? Yes, it was. When did it stop working? Oh, it stopped working this morning. There was a big storm in Houston last night. Houston storms have lightning. Did you try turning it on this morning? Yep. Did it turn on at all? Nope. But it worked last night. Yes. Now I'm starting to hone in on what the problem could be. Was the computer plugged in last night? Well, yeah, I never unplug it. Well, it could be it got zapped. And from there, I'm now going to come up with a possible theory of what it could be. I'm thinking right off the bat, it's probably a power supply. If they're lucky, the power supply gets zapped and a new power supply will fix the problem. So now we test the theory to determine the cause. Well, there are tools we can use to, for example, test power supplies. We can see if they're putting out the right amount of power. If we don't have that, we can actually swap out a known good power supply to see if that solves the problem. So test the theory, establish a plan of action to resolve the problem and implement the solution. Okay, we know what the problem is. We know how to fix this. Now let's go about doing this. What is our plan? This is much more important in the corporate setting because you just can't typically just swap something out and be done with it. Usually you have to come up with, when are we going to do this? What equipment do we need? What's the cost of what we're going to do, et cetera, et cetera. So establish a plan of action. Finally, or not finally, but next, verify the system functions. Don't walk away from a device or a computer until you make sure that you fix the problem. I had a printer installed for me and the technician left before they even printed out a test page. Well, sure enough, the printer wasn't mapped correctly and I had to map it myself. If I wasn't a techie, they'd be getting called back to fix the problem. So always verify the system's functionality. Make sure you fixed what you said you were going to fix. And finally, always document what happened. Document the findings, document the actions, and document the outcomes because you don't know who's going to be working on that computer next. So a little exam tip for you. Know these 6 steps in order. If given one of the steps, know what step comes next. And again, you're not going to be asked to fill in the blanks, but you should know you did this. What is the next step? All right, that concludes Unit 1. We did break it up into 3 different parts because of just how large it was. We're going to continue on with the live streams. I'm hoping you all are getting something out of this, getting some review, getting some knowledge. I think we fixed the audio issue. I won't know until I listen back to the playthrough. But again, would love your comments, your suggestions. We are, like I said, trying to get all this sorted out. So I'm looking at the time. We've been live for 30 minutes, which is about how long I like to last on these live streams. So until later, have fun studying out there. Thank you so much for your attention. I guess I'm supposed to say like, subscribe and share if you enjoyed the video. And until later, goodbye for now.